We are continuing with our punch mixture. Fruit juice and bubbly water are mixed in a ratio of 3 to 5. 3 parts of fruit juice for every 5 parts of bubbly water. Our strip diagram has 3 squares for fruit juice and 5 for bubbly water. Now we will solve problems where one ingredient is known and we need to find the other ingredient. For our first example, how much fruit juice is needed if we use 4 cups of bubbly water? Well, in this case, we have 5 pieces for the bubbly water, so we need to break that 4 into 5 equal pieces. When we do, we get 8/10, or 0.8. That tells us the size of every square in both the bubbly water and the fruit juice rows. So to find the amount of fruit juice, there are 3 squares that are each worth 8/10. That gives us 2.4. So we would need 2.4 cups of fruit juice. Let's think about whether this makes sense. The ratio has less fruit juice than bubbly water because the fruit juice has 3 parts and bubbly water has 5 parts. If we use 4 cups of bubbly water, it makes sense that we need less than 4 cups of juice. So 2.4 cups is reasonable. Next, how much bubbly water is needed if we use 4 cups of fruit juice? Well, for this one, fruit juice has 3 parts. So I need to take that 4, break it up into 3 equal parts. When I do, I get 1 1/3. So each square, each part will be worth 1 1/3. Bubbly water has 5 parts. So 5 times 1 1/3. This is the same thing as 5 times 4/3, which is 20/3, or 6 2/3 cups. So you would need 6 2/3 cups of bubbly water. This answer is more than 4 cups, which makes sense because the mixture uses more bubbly water than fruit juice. Students may not love fractions like 20/3, but this is a good opportunity to focus on meaning. The reasoning is 3 parts of fruit juice equals 4 cups. So 1 part equals 1 1/3, or 4/3 cups. Then 5 parts of bubbly water equals 5 times 4/3, or 20/3 cups. Now, let's name the 3 types of problems we've been solving. Sometimes we know how much one part of the ratio is, and we are looking for the total amount. Sometimes we know how much one part of the ratio is, and we are looking for how much of the other part is needed. Sometimes we know the total amount, and we are looking for one or both parts of the ratio. The strip diagram helps in all 3 cases. Let's use a short example for the first type. If the punch ratio is 3 parts of fruit juice to 5 parts of bubbly water, and let's suppose we know we have 6 liters of fruit juice. How much total punch can we make? Fruit juice has 3 parts, so each part is 6 divided by 3, or 2. So each of my parts is worth 2. I actually want to know the total amount of punch. There are a total of 8 parts that are each worth 2. That gives us a total of 16. We can make 16 liters of punch. That is the structure. Find one part and then use it to find what you need. You are doing excellent work. Strip diagrams are useful because they give us one consistent way to understand many different types of ratio problems.